second half of our project for today. So we're just investigating what first and second differences mean with respect to lines and quadratics or parabolas. Now, clearly, if I take a look at this problem, y is equal to 2x minus 5, we're going to substitute all these numbers in and get the numbers very quickly. Now, just to remind you how to do this, so when we have the y value equals 2x minus 5, what we would do is we would literally just go and take y is equal to, and just substitute the x value that we're looking at. In this case, I'm looking at x is 0. All right, and when we do our calculations, minus 5, this is 2 times 0 is 0, minus 5, which is just negative 5. And when we go and fill out the rest of this, we're good to go. So we got minus 5, minus 3, and minus 1. So now, when you hear the term first differences, what it really means is we're literally taking a look at 9 and negative 7, and we're finding the difference between them. So we're putting negative 9 in brackets minus negative 7 in brackets, and then punch that in the calculator, and we get negative 2. When we do that again for the second one, the second level here, negative 7 and negative 5, we end up with negative 2 again. And we do the same again and again. Now just copy that, and you'll notice something peculiar. Pause and just copy that down. And that is just literally first differences. I'd like to make sure that you all know that this is actually video 3C for lesson 3.1. Now let's move on to the next problem here. So the next problem has exactly the same concept as before. So now let's just go through and find those values. When we punch these in, we do the calculations, we calculate, and then all we have is this for our y values for our problem. So now, when we do this, when we do our first differences, we do the same thing that we did upstairs. So what we did was we compared 14 and 8 by subtracting. Now that I've done that, what we're going to do is we're going to do the same thing for the next problem. The next set of two. Notice always the top minus the bottom one. Top minus bottom. And we do the same again and again. And we end up with 6, 6, 6, and 6. Now, what this tells us is it tells us something about first differences with respect to a line. So each of the above equations represent lines in their point tables. What do you notice about the first differences of each of the tables for each line? So if I look at this, I've noticed that the first differences are the same for lines. So if you do the first differences and all the first differences are the same, then it is a line. If it doesn't work, then we have to check something else. So if it doesn't work, then we say that it's not necessarily a line. But since we just learned about this thing called quadratics, we're going to try a second set of differences to see if that will give us something. So just copy that down, and then we'll move on to the next topic. So now, in this equation, y equals x squared minus 4. I'll tell you why y equals x squared minus 4 is a quadratic. This is a quadratic because the power on the variable x is a squared. The biggest value is a squared, so it is a quadratic then. Now, let's go and fill out the rest of this sheet. So when we go and plug this in, sometimes you want to be able to calculate that quickly. So let me show you how to do that in DES. So our equation is y equals x squared minus 4. So just like before, what we used to do is we'd always just go and create a new table. And then we're going to change our x value, x1, to just the letter x. Now remember, our original equation was x squared minus 4. Now remember, this y column represents what we want it to calculate. So y is equal to, well, it's x caret squared plus, oh wait, minus 4. So when we calculate that, notice it's giving you an error right now. The reason why it's giving you an error is because it doesn't know what x value we want to calculate. So we're going to start at -2. We're going to punch in -2 here, and then it'll calculate 0. Then we're going to tell it how much we want to step for each one of our x values. So now I'm just going to increase x by 1, and then we get the next point, the next point, and the next point, and we can keep going as much as we want to get all the points for our parabola. So like I said, all it did was it went and just calculated all those points for us. So we got 0, -3, -4, -3. And now, so here's how first differences work for this problem. So we start by basically just calculating the difference between these two, then the difference between those two, right? Now, the fact that we don't have these means we have to go and calculate them. So we're going to get -3 and 0 here. So now what we have to do is we calculate our first differences between -4 and 3. We're going to get that. We're going to do the same for -3 and 0. So it's going to be -3 minus 0 equals -3. So now we have to calculate the second differences. So the second differences are basically just the calculation of the difference between the first differences. So 3 minus 1 gives us 2. We do the same again for this one. And we end up with 1 minus -1, which gives us 2. Notice how I always use brackets here. And we do the same for the last one. So that's peculiar. It works for second differences, but it doesn't work for first differences. Okay, let's go and take a look at our next problem. So now we have y is equal to 2x squared plus 3x minus 1. What I want you to do, take a moment and calculate this using Desmos. Calculate the y values, 2x squared minus 3x, sorry, 2x squared plus 3x minus 1 in Desmos and get these y values. Then we'll do the first difference. By punching this in the calculator, you're going to see something like this. And now we'll just fill in our information for our chart. So that's what we get for our first column. So now let's do the first differences for each of these values. So you get something like this. Always top minus bottom. -2 minus -1 is -1. Same thing for this one, and same thing for this one. Copy that. Now let us do the second differences again. So by doing the second differences, you're going to get 3 minus -1, which gives us 4. Then we're going to get 1 minus -5, which gives us 4 again. And the same thing again. So what this tells us, it tells us that if we have our second differences, right, and it's a quadratic, i.e. its maximum power on the x term is x squared, then our second differences will be the same. Now, there's also one other thing I want you to recognize. So this we're eventually going to take a look at later. So when we go to the lowest part or the highest part of the parabola, the steps, the growth for the first differences will always be 1a, 3a, 5a, and then 7a, where a is the variable, not the variable, the coefficient that sits in front of the x squared term for this thing. Y is equal to ax squared plus bx plus c. Now we'll take a look at that later in our next lesson for the week, which you'll get on Wednesday. So what's true about the second differences for the quadratic relation? So you should notice that for the second differences, if we have a parabola or a quadratic, remember, that the second differences are the same number for quadratic relations. So if the first differences are the same, then we know it is a line. If the second differences are the same, then we know it's quadratic. If either the first thing, the line thing doesn't work, or the quadratic thing doesn't work, then we have no possible way of knowing what it is. So it's neither linear or quadratic. And finally, this is our final topic for the day. So first thing I want you to remember is that a quadratic looks like something like this. Y equals ax squared plus bx plus c. Now also, the vertex is the topmost or the lowest point. And the other thing you should recognize is that the axis of symmetry goes through the vertex. Now these 2 points here are the vertex, and then these things here represent the axis of symmetry. Okay? Now, the next thing that I want you to remember is this. For lines, the first differences are the same, and then finally, for quadratics, the second differences are the same. Now, if either of these things if both of these things both fail when you do your calculations, then you say it's neither a linear nor a quadratic, and we're done. Now your homework, you're going to go and do task 3.1, number 1 through 3, and you're going to do Desmos for 2 of the questions from 5 to 7. Then I want you to show all your solutions either on paper or on the computer, and I want them uploaded to FreshGrade. And there's a challenge for question number 8, which is very difficult.